Hi, my name's Ashton Creek, and my presentation is over geopressured geothermal energy. But to start a little further back, there are many types of energies. You can see all the energies listed being mechanical energy, thermal energy, geothermal energy, nuclear energy, chemical energy, electromagnetic energy, sonic energy, etc. All of the different energies that we can and have used that are obtainable for society to use as energies. Now, obviously, some of these are going to be used a little less frequently than others, such as mechanical energies are going to be used more often than, let's say, gravitational energies to produce things like electricity or to power cars. It doesn't work interchangeably. Now to narrow in a little bit more into geothermal energies. Geothermal energy is an energy produced by the inner heat of the earth. The slow decay of radioactive particles in the earth's core, and this process happens in all rocks, produces the geothermal energy. There are a few types of geothermal energies, including hydrothermal, geopressurized, hot dry rock, and magma, that all produce a type of geothermal energy. Alright, now let's zoom in even more into geopressured geothermal energy. This energy resource is a deep sandstone reservoir of hot brine under very high heat and pressure that have dissolved methane in it. The U.S. Gulf Coast actually contains a significant amount of geothermal energy and dissolved methane in geopressured aquifers, super deep, miles below surface. The northern Gulf of Mexico is the largest of the geopressured geothermal basins where they recover this energy, and obviously that's in the United States and is one of the best known, mainly because it's been explored the most and the production in this area has been the most abundant of energy through this process. Just like any other energy source or mining distribution areas, the amount of production relies heavily on where the site of extraction occurs. For example, in some places such as Texas and Louisiana, there are sites that have the potential to produce a lot of product for energy through geopressured geothermal energy. Okay, this is actually very interesting, especially when you talk about obtaining energy. The Gulf Coast is a hot spot for geothermal energies, and this is because it has abnormally high temperatures and pressure thousands of miles deep, and there is a lot of geothermal energy and dissolved methane in these reservoirs super deep in the ground, meaning the potential for two types of resources of energy production are there, being of natural gas and heat. Both of these are in abundance in these areas. Brine reinjection is a method that can be used in geopressured geothermal energy mining. When they're mining for these energy resources, specifically for the geopressured geothermal energy, there's a possibility of minimal environmental impact through brine reinjection, and this happens after extraction of the heat and energy and methane, where the brine is then reinjected into the aquifer from where it came. That's the general idea behind brine reinjection, and this does two things. Number one, it gives a sustainability token to the companies performing these extraction methods. Number two, it saves them money, not having to extract and then dispose of. Now you're extracting and you're replacing it back in there. And this can kind of also lead to another sustainability side of you're re-putting that brine in there, and it can then regenerate more heat and more methane. No system is perfect though, so of course brine reinjection does come with its own issues and potential issues. It could potentially cause harm to the environment through pollution of the aquifers, through contamination once they re-inject that brine. Who's to say it doesn't slip one way or the other, and then you've completely contaminated an entire aquifer that produces water for, thousands of people. Brine reinjection can also be in a relocated format. So initially, the idea behind it was we take the brine out and then we put it back in right where we took it out from. But there is the side of they can take the brine out and then they'll go re-inject it somewhere else that's not from where they took it, which gives statistically even higher possibility of this brine contaminating things such as water aquifers and then other pollutions. Now, we talked about there being two types of energies that can be obtained from the geopressure geothermal energy aquifers, and heat is a very big energy source from these aquifers. So to obtain this heat located in the ground under high temperatures and high pressure, they use a system called binary cycle, which is the main method of extracting this thermal energy from the ground. The binary cycle system, as the name entails, it consists of two cycles. Geothermal fluid goes to the heat exchanger, then vaporizing secondary fluid, which has a low boiling point, and then the secondary fluid expands in vapor turbine generating electricity and condenses in the condenser. What's cool about these condensers is that they don't actually use refrigeration techniques to cool and condense the liquid back. It does it at room temperature already, so it cuts out having to use energy to power a refrigeration machine to do it because it just does it by itself. And then after it condenses in the condenser, it returns to the heat exchanger. Something really cool and important that for an environmental aspect of these is there's no surface disposal of the brines themselves, and there are no direct emissions of gases into the atmosphere during the cycle system, during either one of the two cycles of the binary cycle system. So as the geothermal fluid flows in a closed cycle, it is then re-injected in the reservoir after the heat extraction. Obviously, with an energy source that uses methane, there are going to be issues surrounding greenhouse gas affecting the environment and, a negative sustainability side to it. Even if the methane can continue to dissolve into re-injected brine, time and time again, there's still the issue of using this as an energy source due to greenhouse gases affecting the environment and inevitably contributing to climate change, which we're already struggling with. Geopressure geothermal energy production calls for a more sustainable approach than others, such as coal, by showing statistical evidence of drill sites not contaminating air quality during extraction. So it's not just pushing out a bunch of combustion or releasing BTEX from drill sites to contribute to climate change and greenhouse effects and things of that nature. However, this is not to say there is no pollution. Since methane is one of the products readily extracted through this process, combustion is to come from the methane later for energy producing purposes, which in turn causes pollution and contributes to the global warming crisis that we have going on right now. So just because this may be a better option than mining coal and other things and then using combustion to create the energy, it doesn't mean that it's not affecting our environment or still causing pollution.